Welcome back, aliens. My name is Naveen Reddy, and let's continue this series on blockchain. In this video, we will talk about cryptography. The blockchain works on peer-to-peer network, which simply means you have multiple nodes and we don't need a central server. Whatever we do nowadays is based on some server, right? Example, if you are working on Facebook and if you want to communicate with your friend, we have a Facebook server in between. Same goes for transaction. If you want to send money to someone, we need a bank in between. On the other hand, when you talk about peer-to-peer, we don't need a central server. This is not something which is very new. It's there from a long time. If you remember Napster, it was built on peer-to-peer network, which simply means you have multiple nodes or people, they want to share music for free, of course the pirated one, and they can do it using peer-to-peer. Example, let's say if you have 4 people here or 4 nodes, A, B, C and D, and if A and B, they have a music album with them, the same music album, and if C wants the same album, he can download from A and B at the same time. So maybe half album from A, half album from B, and then at the same time, C can also upload the album so that D can download it. And that's how peer-to-peer works. We don't need a central server in between. Torrent also works on peer-to-peer network. If you have ever used Torrent, you know what I'm talking about, right? We have seeds, we have peers. So P2P is awesome. But it doesn't matter what type of network you work with, we have 4 big concerns. The first concern is confidentiality. The second one is integrity. Third one is non-repudiation. And the fourth one is authentication. So let's talk about the first one, which is confidentiality. So let's say if you are working on this peer-to-peer network and if you have, let's say, A and B, we also have C and D. Let's talk about them later. So we have A and B. Let's say A want to send a message to B. Now this message can be anything. It can be a simple message. Let's say hi, hello, or it can be very confidential. Let's say your bank details. And if you are sharing those details on the network, and which is open, it can be accessed by anyone, right? Let's say we have C in between and C says, hey, A is sending a message to B and C can actually read it. That's something which we don't want, right? We want our data to be confidential. It can be a simple data or a very secret, but everything should be confidential. So that's one thing we want to achieve. The next thing we want to achieve is integrity. So let's say if A is sending a message to B, and of course we don't want anyone to see that message. But let's say it's a very simple message and the message is, hey, let's meet at 6 p.m. Now, if someone else is able to see that message, that's fine with me. But let's say C comes in between and say, hey, I have read the message, okay, but then I also want to modify it. C modifies the data by saying, hey, let's meet at 5 p.m. That's where the problem starts, right? Someone in between is changing my data. So the data which is received by B is different from what A is sending, and that's where we have an issue of integrity. We don't want our data to be modified on the network. The third one is non-repudiation, which simply means no one should say that you have not done that or I have not done that. Example, let's say if A sends a message to B as by saying, hey, let's meet at 6 p.m. And let's say if B showed up and A is not there, after some time A will say, hey, I have not sent you any of that message. So we don't want that. If A is sending a message to B, there should be a proof that A has actually sent the message. So that's about non-repudiation. The fourth one is authentication. So let's say B has received a packet and the packet or the message is, let's meet at 6 p.m. and the message is sent by A. What is the guarantee that A has actually sent the message? It can be C as well. So maybe C has sent the message in the name of A or maybe some other identity, and that's where the problem starts, right? We don't want anyone else to send a message on someone else's behalf. And that's where we have an issue of authentication. So how do you solve this 4 problem? And that's where we have a concept of cryptography. Now if you talk about this term cryptography, it's basically had 2 terms. The first one is crypt and second one is graphy. So crypt is basically means hidden or secret. And graphy is basically writing. So that means when you send a message, you have to convert your message in such a way that someone else will not be able to read it. Now when I say someone else, it should be readable only by the receiver but not by anyone else. How do we do that? So what we do basically here is we use a concept of encryption and decryption. Now what it means, so let's say if you have A and B, if A want to send a message, so that message will be first encrypted and we will get something new known as a ciphertext. Now ciphertext is basically an unreadable format, and then this unreadable format, ciphertext, will go to the receiver end, let's say B. Now B will be able to see that, but unfortunately the moment you encrypt a message, you can read it only when you are decrypting it. That means if you want to read the message, you have to decrypt it. How will you do that? The only way to encrypt and decrypt something is with the help of a key. So if A and B has a key, they can encrypt and they can decrypt. No one else can do that because they don't have a key with them. So based on these keys, we have two different types of cryptography. The first one is symmetric key cryptography. The second one is asymmetric key cryptography. And what are those? That we'll discuss in the next video. I hope you enjoyed this video. Let me know in the comment section and do subscribe for further videos. Bye-bye.